The next part of the podcast is about gravity. So we know that gravity is a force which acts between all masses. So it is an attractive force. Which acts between all masses. And it is always attractive. So the greater the mass, the greater the gravitational attraction. The further away the mass is, the less the gravitational attraction. Now, people get mixed up between mass and weight, and it's your weight, which is a pull of gravity on your body. So, if you stood on the moon, you would weigh less than on the earth, but your mass is still the same. So traditionally we've always talked about weighing ourselves and our weight is so many stone. That's actually your mass. If you weigh yourself in kilograms, that's also your mass. So the scales are actually giving you a mass, not a weight. Unfortunately, when we go to shops and things, everything on the side of the food packets, it says net weight equals so many kilograms. Those are actually masses. And that's why it's so difficult for people to kind of get their head around the fact that it's actually weight. Weight is measured in newtons, not kilograms. So if you stand on the moon, you would weigh less than on the earth. Now your mass will be the same, but the force of gravity on the moon is much less. And so if we just see the bottom statement here, this is because the moon has less mass than the earth, so the moon's gravitational pull, I haven't much room to write that in, the moon's gravitational pull is weaker than the earth's, and so you actually weigh less. Okay, the difference between mass and weight. Now, mass, we just said there, was the amount of matter in an object. In other words, the number of molecules or particles, and that amount of matter is your mass. But weight is a force of gravity. Acting on an object. So mass then is measured in kilograms, and weight is a force, so weight is measured in newtons. So if you have a mass of 10 kilograms on the earth, that mass actually has got a weight. So if you had a mass of 10 kilograms on the earth, its weight would actually be 100 newtons. So we calculate that using an equation, and we calculate weight anywhere using the equation weight equals mass multiplied by acceleration due to gravity. Now we shorten that to W equals mg. Now g depends on the planet you're on. We are of course on the earth, and g on the earth has a value of 10. It's measured in meters per second squared, or it could be measured in newtons per kilogram. But its value is 10, so you have to know that. You won't be given that in an exam, you'll be expected to know that altogether. To use it in an exam. Now we're going to do a couple of calculations here. A man has a mass of 65 kilograms. What is his mass and weight on, first of all, the earth, and then on the moon, where g is equal to 1.6 meters per second squared. So you can see the value of g is 10 on the earth, but it's only 1.6 on the moon, so it's much, much smaller. So mass on the earth, that's just a simple matter of writing down 65 kilograms. Now, whenever you go to the moon, The mass doesn't change, so the mass on the moon is also 65 kilograms. We'll do the weight in a different colour. We have to use the equation to calculate the weight. Weight is equal to mass times acceleration due to gravity, and that's equal to 65, and it's on the Earth, so we use a value of g to be 10, and that gives us 650. And remember, weight is a force, and it's measured in newtons, and so you must do that. So again, as usual, an equation, working out an answer and a unit. Weight on the moon, again we have to use W equals mg, but this time our value of g is this value up here, 1.6 metres per second squared. And that gives us an answer of 104, and again it's a force, so it's measured in newtons. So G, or W, is equal to 104 newtons.